This is question 13 from exercise 4.6, further applications. ABC is an equilateral triangle, so we've shown that by indicating equal sides by the little red indicators. The perpendicular to BC, now BC is the bottom of that equilateral triangle, and so the perpendicular to BC at C, so in other words at vertex C, we have a perpendicular line drawn, so BC is perpendicular to CD, so we can see the right angle there. So that perpendicular meets BA produced. Now BA produced means you extend BA and it gets extended all the way to D. So therefore we can see the perpendicular at the perpendicular to BC at C, so we've got a perpendicular drawn at C, meets BA produced at D, and also the perpendicular to AB at B, so we have another perpendicular drawn there at B, meets AC produced, so AC is this side of the equilateral triangle, it's produced down to E, and this perpendicular line BE meets there. And the question asks us to prove that CE is equal to AD. Now, to be able to do that, we need to see which triangles CE and AD are sitting in. So CE sits in triangle CEB and AD sits in triangle ADC. So we need to prove that triangle ADC is congruent to triangle CEB. Now, because we have an equilateral triangle here, we know that all the angles in this triangle are 60 degrees. And we can also see that because BA has been produced to D, that this is a straight line, and if angle BAC is 60, then angle CAD would be 120 degrees. And we can also see that if the angle here at C, which is angle ACB, is 60, therefore angle BCE would also be 120 degrees because we've got a straight line there at C. So we can start writing that down, okay? So we want to say that angle BAC is, so angle BAC is 60 degrees because it's an angle in an equilateral triangle. And then we can say that angle DAC equals, so this angle here, DAC is 120 degrees because we've got adjacent angles on a straight line. Similarly, we can say also down at angle ACB, that angle ACB here is 60 degrees because it's also an angle in an equilateral triangle. And again, this angle here, angle BCE, again will be 120 degrees as well because we've got a straight line there. I'll just condense this a little bit. It's a little bit too spaced out. So we've shown that angle DAC is equal to angle BCE and that they're both 120 degrees. The other thing, if this angle here, if ACB is 60, and because this is a right angle here, then angle ACD will be 30. And similarly over here, we've got a 60-degree angle in this triangle, and because we've got a right angle here, then this angle here, angle CBE, will also be 30. So we'll write this down as well. So the first thing, angle ACD is 30 degrees. And the reason for that is that here these two angles are adjacent angles in a right angle. And similarly down here, we've got that angle ABC is 60 degrees because it's an angle in an equilateral triangle. And so this angle here, angle CBE, will be 30 degrees because we have a right angle there at B as well. Okay. So I've just marked the information that we've got so far, that angle DAC is equal to angle BCE, and they're both 120, and these are indicated by the dots. And we also know that angle DCA, this angle here, is equal to angle CBE, indicated by this little arc here, and they're both equal to 30 degrees. So we do have two sides and an angle, sorry, two angles and a side in both these triangles, therefore they're going to be congruent. So we're going to write this out now. It's going to make a little bit more space. So we can now say that to prove that the triangles are congruent, we can say that firstly, as we can see, we know that AC equals BC. AC equals BC because they're sides of an equilateral triangle. We can also now state that angle ACD, so ACD equals angle CBE, which was proven above. I'll just move this back down, and they're both 30 degrees. And we can also state that angle DAC, so DAC equals angle BCE, which is 120 degrees. So those angles with the dots are 120. That was also proven above. And as we said before, that's the three pieces of information that we need. And so the triangles are congruent by AAS. And because they're congruent, therefore we can say that CE here is equal to AD because they are matching sides of congruent triangles. And that's the end of the proof.